Hi folks! Today I'd like to share with you something that we created for my Earth and Space Science class, and that is the Hertzsprung-Russell diagram that you see behind me. A Hertzsprung-Russell, or HR diagram, is a tool that plots a star's surface temperature against its luminosity. So let's talk about what this diagram shows, what went into making it, and how students can use it to learn about the spectral classification of stars. The Hertzsprung-Russell diagram is a tool used in astronomy to classify stars and understand their life cycles. It plots stars based on their surface temperature, which decreases along the x-axis, and luminosity, which increases as you move up the y-axis. Most stars, including the Sun, lie along the main sequence, where stars spend the majority of their lives fusing hydrogen in their cores. When stars run out of hydrogen, they move off the main sequence into the giant branch, where cooler, highly luminous stars like red giants and supergiants are located. When smaller stars reach the end of their stellar life cycles, they become white dwarfs, which are extremely hot but very dim stars because they're so small. Our Sun will one day become a white dwarf. The Hertzsprung-Russell diagram allows us to see some trends. Hotter, main sequence stars are more luminous and reside in the upper left of the diagram, while cooler, dimmer red dwarf stars are in the lower right. Making this HR diagram is a great activity for students who have minimal experience with designing files for 3D printing, because the entire diagram can be made with two basic shapes, circles and rectangles. The only other thing students need to do is to add text. If it's your first time doing this activity, you can have students design their own stars. You could give them a list of stars to research and ask them to record the star's common name, temperature, and luminosity. I came up with the numbers for luminosity by making an HR diagram in a spreadsheet to get an idea of scale. I printed the temperature labels in the same color as the expected surface temperature of those stars. Of course, nothing about this is exact. I did the same for the spectral class labels, which can also be printed at the same time as the temperature labels to minimize filament changes. I assigned a filament color that best matched the color of these stars and corresponds to their spectral class. O stars are blue, B stars blue-white, A stars white, F stars are yellow-white, G stars like our Sun are yellow, K stars orange, and M stars red. Once the stars are made, you can resize them to the proportions that you want. For example, I print the white dwarf stars smaller than the main sequence stars, and supergiants like Betelgeuse rather large. It's worth noting that these stars are obviously not going to be to scale, considering that white dwarfs are about the size of the Earth, while Betelgeuse is hundreds of times larger than the Sun. If students are designing the stars, make sure to do a quality control check first to ensure there's no issues. I like to glue magnets to the back of my stars so they can be removed easily. That way, I can modify the activity next year by having students choose stars instead of making and 3D printing them. Each student will pick a random star out of a box, research it, and complete a worksheet. Then they will take their star and plot it on the HR diagram. Once the HR diagram is complete, you can use it for activities such as plotting the evolution of the Sun. I also like to ask questions about the diagram. I may call on a random student to point to a star that's fusing hydrogen, or one that's reached the end of its life cycle. I think this is a must-have for anyone who teaches astronomy or Earth and space, and it also adds a nice splash of color to the room. Overall, I'm very happy with it. In the next video, my Earth and space science students will be using their creative thinking and engineering skills to take a 3D printed block and construct an ultra-lightweight vehicle to mimic the concept of a solar sail, in the hopes of one day maybe exploring some of these. Hope you enjoyed the ride, and don't forget to like and subscribe.